we are going to discuss about op-amp. So what is op-amp? Op-amp is a device that accepts a varying input signal to become a larger output signal. Okay, so there are several types of applications for linear applications, but today we are going to just focusing on this application, which is inverting summing amplifier. Alright, so in order for us to get the formulations inside the inverting summing amplifier, so according to the virtual earth concept, so V plus equal to V minus, and also I plus equal to I minus equivalent to 0 ampere. But now we know that V plus is equivalent to ground, so which gives us more information of 0 volt. Alright, so let's start with using KCL. So as we know that I1 plus I2 equivalent to IF plus I minus. I1 plus I2 equivalent to IF plus I minus. Right. So I1 is equivalent to V1 minus V minus divided by R1, as well as the others, and plus I2, so V2 minus V minus 2, so divided by R2. Right. So IF is equivalent, as we know that I minus equivalent to 0, so plus 0. Okay, that's it. So we need to rearrange them, and then we become V1, as we know that V minus equivalent to 0 too. So 0, 0. So left with V1 divided by R1 plus V2 divided by R2, and also V minus is 0 minus, right? So then minus V naught over RF, right? So we arrange them in order for us to make V naught is the subject. So V naught equivalent to RF, right, times with V1 over R1 plus V2 R2. So now we can have VO equivalent to minus RF. We exclude, we take out the V1 and V2 in front and put the RF inside, so that will become V1 RF over R1, V2 RF over.
Okay, this is the example of inverting summing amplifier. First, to determine the output voltage V0, if V1 equal to positive 2 volt and V2 equal to positive 3.2 volt. Okay, if V1 equal to positive 2 volt and then V2 equal to positive 3.2 volt, from the derivation formula, V0 equal to negative RF over R1 times by V1 plus RF over R2 times by V2. So insert the value for RF 3 kilo ohm divided by R1, which is 1 kilo ohm, times by V1 is positive 2 volt plus RF 3 kilo ohm divided by R2, which is 1.6 kilo ohm, times by V2 positive 3.2 volt. So calculate the value, we get negative 12 volt for the output voltage. Okay, next, to draw and label the waveform of input voltage V1 and V2 and output voltage V0. So the input voltage is a DC voltage V1 equal to positive 12 volt. So the graph will be V1 over time. Positive 2. So the graph will be like this. Next, for V2 equal to 3.2 volt. So the graph voltage against time, 3.2 volt, and the output voltage is V0 over time. It will have negative value, negative 12 volt. So below, so we get the result of two input voltage and output voltage.